Hi everyone, this is lesson 2.7, Prove Angle Pair Relationships. So in today's lesson, you're going to apply properties of special angle pairs to prove geometric relationships about angles. We're going to learn a few more theorems in this lesson to wrap up chapter 2. So the first theorem that we'll talk about is the right angle congruence theorem. This simply states that all right angles are congruent. So if you have any two angles that you know are right angles, you can set them congruent to each other. So remember though that any theorem, we need to prove that it's true. From last lesson, you learned that theorems have to be proven true. And then once they are proven true, you can use them in other proofs or in other arguments. So here's a proof. So angle 1 and angle 2 are right angles. So that's what we're given. And we want to try to prove that they are congruent to each other. So this is pretty simple. Step 1, and there are 5 steps to this proof if you want to start listing your steps. So step 1 is to state the given information that angle 1 and angle 2 are right angles. And the reason is given to us. All right. Step 2. So what do you know about right angles? Well, based off of the definition of a right angle, you know that their measure equals 90 degrees. So the measure of angle 1 is equal to 90 degrees from the definition of a right angle. And step 3, we can say the same thing for angle 2. The measure of angle 2 is equal to 90 degrees. Sorry, I meant to put measure. And you can rewrite this, or you could just put quotes. That means the same thing as what you put above. And then step 4. So what could we do with step 2 and 3? Do you see a way to combine them? Well, if they both are equal to 90 degrees, if measure of angle 1 is 90 and 90 is equal to measure of angle 2, then the measure of angle 1 is equal to the measure of angle 2. And that's called the transitive property. And we have one more step. So we know that in our last step, we're supposed to say angle 1 is congruent to angle 2, because that's what we're trying to prove. If you wanted to, you can even, right at the beginning, you could put what you're trying to prove at the end, just so you can have it in sight. But what's the reason? The reason would be definition of angle congruence that you learned in the last lesson. Definition of angle congruence, or definition of congruent angles. Okay, so we have proved the right angle congruence theorem. If any two angles are right angles, then they are congruent to each other. So now let's use it in a proof. So we are given that segment AB is perpendicular to segment BC, and segment DC is perpendicular to segment BC. We want to try to prove the angle B and C are congruent to each other. This proof has 3 steps in it. So statement 1, let's write down both of our givens in the same step. AB perpendicular to BC and DC perpendicular to BC. Step 2. Based off of the definition of perpendicular lines create right angles. So, therefore, angle B and angle C are right angles because of the definition of perpendicular lines. Which, if you want to make a side note here, states that perpendicular lines create right angles. Okay, and then because angle B and angle C are right angles, we can say that angle B is congruent to angle C, exactly what we're trying to prove because of the right angle congruence theorem. All right, let's look at a few other theorems. This next one is called the Congruent Supplements theorem and the Congruent Compliments theorem. So it says that if any two angles are supplementary to the same angle, then they are congruent to each other. So for example, if you've got this 100-degree angle and you've got another angle that's 80 degrees, okay, they're they're supplementary to each other, right? So what if you have another angle over here that's also supplementary with 80? Well, that would have to mean then that if these two are both have to be 100, so they are both congruent to each other. So it says if angle 1 and 2 are supplementary and angle 3 and angle 2 are supplementary, then you can say angle 1 is congruent to angle 3. That's the congruent supplement theorem. Don't know if you can hear my dog woofing, but she has heard another dog barking outside. Woof, woof. Okay, maybe not. All right, congruent complements theorem, basically the same thing. We're just talking about complementary angles. So here, angle 4 and 6 would be congruent if they are both complementary with angle 5. All right. So let's go ahead and prove those. So we're going to prove the congruent complements theorem. And I believe that you proved the congruent supplements theorem. Oh no, sorry, we're proving the congruent supplements theorem. You proved the congruent complements theorem in your homework. All right, so angle 1 and 2 are supplements. Angle 3 and 2 are supplements. We want to prove that angle 1 and 3 are congruent. So let's first start off by stating our givens. We're going to write our givens in the same line. You can write them in 2 separate lines. You'll just have 1, 2, 3, 4, 5, 6 steps. So step 1, angle 1 and angle 2 are supplementary. Angle 3 and angle 2 are supplementary. And that's given. Step 2. All right, well, we know that these 2 sets of angles are supplementary. So, is there anything we can say about supplementary angles? What do you know about supplementary angles? What's the definition of a supplementary angle? The definition of a supplementary angle is that the measures add up to 180. So we're going to take that and use it in the next 2 steps. So actually, let's just use it in this step here. So we'll say that the measure of angle 1 plus the measure of angle 2 equals 180. And the measure of angle 3 plus the measure of angle 2 is equal to 180. And that's because of the definition of supplementary angles. The proof for complements is very similar to this process here. Step 3. So, you know that these 2 equations are both equal to 180. So, what other equation could you create, perhaps using the transitive property? You can say that measure of angle 1 and 2 is equal to the measure of angle 3 and 2 since they're both equal to 180. Okay, so from this point, I think you've seen examples like this before. So what would be next is, since you have the measure of angle 2 on both sides of the equation, you can get rid of that, and oh look, we're getting so much closer to what we're trying to prove. So step 4, measure of angle 1 equals measure of angle 3 because of the subtraction property. And then finally, step 5, angle 1 is congruent to angle 3 because of the definition of angle congruence. And that proves the congruent supplements theorem. Let's look at another postulate and another theorem. So the linear pair postulate. So if two angles form a linear pair, then they are supplementary. And if two angles are supplementary, then their measures add up to 180 degrees. Okay, so first we would have to know that they're a linear pair. Well, as long as they're adjacent. So angle 1 and 2 form a linear pair, so angle 1 and 2 are supplementary. And the measure of angle 1 and 2 add up to 180 degrees. So that's the linear pair postulate. Vertical angle congruence theorem. Vertical angles are, want to take a guess? Congruent. Yay. And we kind of already discovered that. But this is our formal proof. So angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. So whenever you have vertical angles, by the vertical angle congruence theorem, you can say that they are congruent. And let's see an example. Well, trying to see which example to do next. Let's go ahead and do this example next. So this is kind of a long one. It has 8 steps, okay, so bear with me here. Go ahead and copy the diagram in your notes. So it says angle ABD is a right angle, so I'm going to mark that in the diagram. And angle CEB is a right angle. So CEB is also a right angle. Okay, so step 1 is our given. Angle ABD and angle CBE are right angles. And that is given. Okay, step 2. So, if they're both right angles, what can you say about them? You can say that they are congruent to each other. So let's go ahead and do that. Angle ABD is congruent to angle CBE. That's because of the right angle congruence theorem that we learned at the beginning. Okay, and then, so here's the tricky part. After this, we are going to use the definition of angle congruence to say that the measure of angle ABD is equal to the measure of angle CBE. And that's because since we're trying to prove that ABC is congruent to DBE, that parts of this right angle are congruent, we are going to try to use the angle addition postulate to kind of help us to separate the two angles from the right angles. So in order to use the angle addition postulate, we have to use measures, since you're adding the measures of angles. So that means that we want to go from congruence to equality for a minute, and then at the end we'll go back to congruence, since that's what we're trying to prove, a congruence statement. So step 4, I'm going to use the angle addition postulate or angle ABD. So let's say the measure of angle ABD is equal to the measure of angle ABC plus the measure of angle CBD. Angle addition postulate. And then we're going to do the same thing with the other right angle, CBE. So the measure of angle CBE equals the measure of angle CBD plus the measure of angle DBE. And same thing, angle addition postulate. Okay, so now let's combine the concept from step 3 to 5. So if this is equal to that, but that's equal to this, and this is equal to that, then we can actually make a new equation using these two set equal to each other from the transitive property. So step 6, we're going to say that the measure of angle ABC plus the measure of angle, might want to write small, CBD equals the measure of angle CBD plus the measure of angle DBE. Okay, and as you're writing, notice what is common on both sides of the equation. So you're going to start seeing that it's going to work out now. It's a transitive property. Okay, so what is common in both sides of the equation? Angle CBD. So we can cross that off using subtraction. Measure of angle ABC is equal to the measure of angle, what's that supposed to say? DBE. And isn't that exactly what we're trying to prove up here? Close. We're trying to prove congruence. So after we do the subtraction, property, we are going to then say that angle ABC is congruent to angle DBE. And by the definition of angle congruence, going the other way. So we were able to use the angle addition postulate, the right angle congruence theorem, to say that the two right angles are congruent to each other, and then the angle addition postulate to set up an equation. And then we were able to get rid of this common angle that they share and prove that the ones we were talking about are equal to each other. And I'm sorry if you can hear my dog chewing on her bone. She's planted her head right next to my laptop and is munching on her bone. So anyways, I'm going to go ahead and end this video. There was one other example, but I'm going to put it in your assignment for the next day because this video is probably long enough. All right, you guys, have a great evening.